Hi, I'm Rick from rktestprep.com, and today we have some interesting SAT-specific math problems. Recommendation is to print out the PDF, try these on your own, and then we can look at the solutions here. So number one, here's a system of equations. K is a constant. For what value of K will the system have no solution? First thing to note is these are lines. We want to think about what types of lines have no solution. Most lines, when you graph them, will intersect at one point, one solution. So what does it mean if there's no solution? Well, that means nothing ever works in both lines, or that they're parallel. And parallel lines, we know, have the same slope. So really, if we put both equations into y equals mx plus b form, you can then just set the m's equal. Now, you could also graph them on Desmos, and we'll look at that in a minute. The reason we're not going to do it that way is because if this is not a multiple choice question and it's a grid in, it might be tough to get the exact value. But anyway, let's get the slope of the first one. You move the kx over to the right side. You divide both sides by 3. And you get that y equals negative k over 3x something something. I don't even care about the rest because all I care about is the slope, the negative k over 3. We do the same thing with the other equation. We move the 4x over, so we get negative 5y equals negative 4x something something. Divide by negative 5, and you get that y is 4/5 x, blah blah blah. So we know that the slope of the one is negative k over 3. The slope of the other is 4 over 5. You set those equal. Cross multiply and solve. 12 equals negative 5k. So k is negative 5/12. Real quick, the reason why it might not pay to graph is if you were to graph it with Desmos. Add your slider. When I go to try to make these parallel, is it negative 2.3 or negative 2.5 or negative 2.4? I don't have perfect eyesight, so it might be tough to get the exact value. And they might even design it so that the answer is negative 2.457, in which case it's going to be tough to get. So obviously with this problem, you could graph it and realize that A is the only close value. But that would be a reason to know how to do this algebraically. Number 2, here's an expression. It's equivalent to bx, where b is a constant. What's the value of b? So the first thing to note is that when we set this expression equal to bx, we have one equation and 3 unknowns, which means you can never solve it with math. There's not enough info. So it means at some point we are just going to be comparing like terms. So sometimes on the test there's no more solving, you're just meant to compare what's in the same spot. We can't compare till we get rid of the parentheses, so we do want to FOIL out that left-hand side. So we FOIL it out, we can combine, or we can get rid of the 3's there. And then we want to start comparing our like terms. On the left, we have two x terms, 3ax minus 3x. Altogether, that equals bx. So we can break those out and set them equal. If you want, you can divide out the x. So it just becomes 3a minus 3 equals b. Next, we want to compare our x squared terms. On the left, we have 3ax squared minus x squared. Altogether, those need to correspond to the x squared term on the right. And what is that? Not exactly a trick question, but there's nothing there. So it's as if it were a 0. So altogether, 3ax squared minus x squared has to equal 0x squared. You can divide out the x squareds, add the 1 over. I would not even solve for a because notice you're going to plug in the 1 for 3a. So that's why b is negative 2. So unique to the test, something you probably don't encounter too much in school, is that sometimes you're not solving anymore, you're just comparing what's in the same spot and making those line up. And if something doesn't appear, it's as if it were a 0. Number 3, the equation here has these solutions. What's the value of n plus k? So we see the roots, we know we're not going to be able to factor it. It should say equals 0. We can't factor it because there's roots. So that means quadratic equation. Now on the test, a lot of these problems you can put them into Desmos, but the way they've asked this question, you can't. And so we are going to have to use the quadratic. So we do negative b plus or minus the square root of b squared minus 4ac all over 2a, negative 8 plus or minus root 52 over 2. Notice up here there's no fractions, so we're going to have to get rid of the fractions. So we want to factor out a 4 there. So it'll be negative 8 plus or minus root 4 times 13 all over 2. The root 4 will come out as a 2. And that'll allow us, now both terms up top are divisible by 2. So it looks like that. And in school, that would be the answer. Those are the solutions. But on the test, sometimes you have to go one step further. Here they're saying, let's rename this thing as n plus or minus k. So what's n? Well, n's the number out front, the negative 4. And then what's k? This is a little tricky. K is in the root, just like 13 is in the root. So k is just 13. So now what's n plus k? 13 minus 4 is 9. So that's why the answer is 9. So sometimes they will structure it so that you can't use Desmos, and this would be one way. Number 4, volume of a cylinder. What's the volume of this other one? So they do give you volume of cylinder. You can pull that up at any time on the test as a pop-up. It's pi r squared h. So the volume of A, cylinder A here, is going to be pi r squared h, or 44. We are going to hold on to that till the very end. We're not going to use that fact till much later. What we want to do is come up with an expression for this new one, the volume of the new cylinder. And we'll write it in terms of the other one. So it's going to be pi r squared h, but the radius is half this other one up here. So it's going to be 1/2 r. It's got twice the height, so instead of h, we're going to do 2h. So we can simplify that a little. You square the half, so that's a 1/4. You times it by 2. And I'm going to combine those numbers and move them to the front. I'm not going to put it in the calculator with the pi. You're almost never going to put pi in the calculator. The reason we write it like this is because now we want to think, do we know something about pi r squared h? Well, if this is the same r and h from the beginning, then pi r squared h is 44. So this whole thing here is 44. So sometimes you can sub in for an entire expression without even knowing the pieces. So that's why the volume of the new one is 22. And we don't know r, we don't know h. It's impossible to know them because there's not enough info. So hopefully we're noticing this pattern. Sometimes on the test they don't give you enough info to solve it the traditional way, and we need to know some of these shortcuts. Number 5, conditional probability. Here's a table, the results of a survey, how often people check their email. What's the probability that a user answered rarely, given that they did not answer always? So this adds up to 100%. I would just plug in numbers, like I would just let these be the numbers. Say there's 34 people, 38 people, 100 people total. Always try to use numbers that are convenient. So they're saying given that the user did not answer always. So we're not counting these always people. It's just the other parts. So any probability is always a part over the total. The total here is not 100 because we're saying we already know that the user did not answer always. So instead of 100, we take out that 73 and the total is 83. Now, how many rarelies are there? That's the 38. So you throw that in the calculator, you get approximately 40.46. So sometimes for these conditional probabilities, you're blacking out entire rows or columns and just looking at part of the table. And number 6, here's this equation. Here's another one. What's the value of this expression? We know that this is a clue. Anytime they ask you for an expression on the test, they're telling you it's going to be easier and faster to get that directly rather than solving for A and B individually. So always take the clue. So we want to try to get a common base over here to be able to get rid of the x. It requires us to know what we do when we divide what we do to the exponents. A simple example I give sometimes is I'll ask people what's x to the 7 over x to the 2. Well, clearly those 2 on the bottom are going to cancel out 2 of the ones up top, and you get x to the 5th. That's a way to remember that when you divide, you subtract the exponents. So over here, it's going to be x to the a squared minus b squared equals x to the 20. You can now drop the bases and bring down the exponents. And so together with a plus b equals 4, that's technically a system you can solve, but it's kind of a mess. If you do substitution, you'll end up having to factor. It takes 10 steps. The shortcut is to see how can you get an a minus b all at once. And then it comes by noticing that we got a difference of squares over here that we can factor. A little unusual that the second one's a variable, but we can deal with it. So that's that classic difference of squares. So that creates that a minus b that we want to solve for. If only we knew what a plus b equaled, then we could get there. And notice they give us that exact value. So you can divide the 4, and you get that a minus b is 5. Individually, a and b are messy fractions, but notice that difference we're trying to find was a nice round number. So always take the clue is the deal. Email me if you have any questions on these. Like the video if you liked it. Subscribe to the channel if you want to see more content like this. I've tutored over 2,000 students for the SAT over the course of 15 years. So we have a lot of insight into the test that is helpful. Good luck.